Next topic is actually performance. One of the important issue in networking is actually performance. That indicates how fast, how better your networking is. Whether your network is a good or a bad. That can be explained by some of the property like bandwidth, throughput, latency, or jitter. The first one we are learning here called as bandwidth. Bandwidth can be explained in two different contexts. Two different measures for bandwidths are bandwidth in hertz, bandwidth in bits per second. These two measuring values we are generally used for bandwidth calculation. The first, bandwidth in hertz, is actually used when you are transmitting data in analog format. But bandwidth in bits per second is used when we are sending some data in digital format. The first one, bandwidth in hertz. Bandwidth in hertz is actually a range of frequencies contained in composite signal. That means in one composite signal, how many different frequencies of simple sine wave can be added, or the range of frequencies a channel can pass. That is called as bandwidth in hertz. Total number of frequencies we can transmit in composite signal is actually called as bandwidth in hertz. For example, we can say the bandwidth of subscriber telephone line is 4 kilohertz. That means we can transmit 4 kilo different frequencies of signals. 4K of different frequencies of signals. That is called as bandwidth in hertz. The next one is called as bandwidth in bits per second, which explains the number of bits we can transmit within a second. Through medium, how many bits we can transmit in 1 second is actually called as bandwidth in bits per second. For example, in fast Ethernet, maximum we can transmit 100 megabits per second. That means 100 megabits can be sent in 1 second. There is a relationship between bandwidth in hertz and bandwidth bits per second. As the bandwidth in hertz increases, the bandwidth in bits per second is also increased. The next one is called as throughput. Throughput measures how fast we can actually send data through a network. For example, if you have a bandwidth of B bits per second, but we can only transmit T bits per second through that medium, T is always less than B. The bandwidth indicates the potential measure of the link. That means the maximum data we can send through that medium, the maximum data we can transmit, that gives the bandwidth. But when we are transmitting data over that medium, here the throughput means the actual measurement, how fast we can send the data. Here the throughput is always less than bandwidth. Whenever we are transmitting data, how many bits we can transmit, that is measured by throughput. If you see this diagram properly, here if this is actually a road and we are transmitting some here cars, here all the cars are compact, so this is called as bandwidth. But when we are actually transmitting the cars, they are having some distances here, not actually compact. So that is the throughput. Means we can transmit 24 cars per second here, but actually in real life we can transfer 20 cars per second here. Here. One example is given in our technical field. We may have a link with a bandwidth of 1 megabits per second. But the devices connect to the end and the link may handle only 200 kilobits per second. This means that we cannot send more than 200 kilobits per second. 200 kbps means it's a throughput and 1 mbps means it is a bandwidth. We can transmit only 200 kbps even if you have 1 mbps of bandwidth.